Our next speaker is an independent. They have done a ton of interesting stuff in their time, including making the docs for React Native be awesome. I am going to get out of the way. Oh, I've never seen such amazing color coordination. That is absolutely bang on. So one of the other things our next speaker also said, they said, I put a lot of work in. And pretty clearly, that is the case. So let us have some better engineering with right-sized models. Rachel-Lee Nabors.
Thank you for that lovely introduction, James. And it's good to see you all here. I live in London, but I have American heritage, as you can tell from the accent here. I'm Rachel-Lee Nabors, and I have worked on the standards that power today's web. We have had a lot of people who work on the back end here today, but I'm more of a client-side person. I've worked with Mozilla on Firefox's dev tools. Get a little bit of feedback. The W3C on web standards and Microsoft's Edge browser, and of course, even on React. How many people here reference react.dev? Okay, good. That was my pandemic baby. It was fun working. And how many people here have a web background? I'm curious. Lovely. And how many of you are machine learning background? All right, well, at least I'm kind of curious about everyone else. I'm sure there'll be a survey. Today, I'm going to help you use AI without setting the world on fire. How many of you are concerned about the environmental impacts of AI? Oh, I love how conscious you are. The rest of you are evil. So we're talking sustainable AI today. Now, every time you reach for a foundation model like GPT-5 or Claude, it's going to cost you. Monetarily, it's going to cost your users. It's going to cost the environment. How many of you are actually using these frontier models in production today? Okay, well, let's see if you have a different idea about that. So how exactly is it costing us? Let me elaborate. So security, cost trust. Sending data to remote servers always carries the risks of exposure, interception, and retention by third parties. We have had cases where the use of remote AI chatbots led to sensitive business data being stored, breached, or leaked. Latency costs the user experience. Research on mitigating response delays in LLM-generated chats in VR found that a 4-second delay, as it were, has had a substantial degradation on the user's experience. This is quite down from similar studies in the 1960s that found a 10-second delay was the limit of user patience. And it costs your business. Third-party inference costs are, compared to the steady linear growth of API costs, rather uncontrollable, and agents eat into compounding levels of inference the more you use them. Training and inference cost the human species. Most of the cost for LLMs usage comes from the training, but the ongoing cost of using the inference has a growing impact on resources like electricity and water. Thus, as we continue to use LLMs more and more, we can expect these inference costs to begin to dwarf the training costs. In fact, that is the bet that big tech is making. And of course, if you aren't connected, it won't work. If you do not have the internet connection with which to make a call to the large language model at a data center, you have a brick of a piece of software. So not so great for the client side. I'm not an AI doomer though. Believe it or not, I'm actually a centrist, and nobody likes the centrists because you're not committed to one cause or the other. I'm not going to hand wave about inference costs one day going down because, oh, the chips just need to be better and we have all these experiences where costs go down. I come from the free and open web, which has a local first ecology and likes to do things Spartan and efficiently. Foundation model companies, they want to sell us access to models that can do everything. They are chasing features. And that's great for them, but we're talking production here. Production is very different. Now, let's take a look at some models that are small in size and power consumption compared to a foundation model. Task-specific models do one thing really well, and they're widely available in the open source community. Here's a cheat sheet. We're not going to spend a lot of time on task-specific models because I've only got 20 minutes. But if a camera is pointing at something, you can probably use a vision model like MobileNet, YOLO, or MediaPipe. If a microphone is recording, you can use an audio model like Whisper or WAV2Vec2. And of course, chat, translation, analysis. Consider a small language model like Gemma or Qwen. Anybody here using small language models? Okay. Anybody here not know what a small language model is yet? Too late, I'm going to tell you. There are times when we do need the power of GPTs, but we probably don't need the sum total of human knowledge in a black box in our pocket. Most of the times we don't need that. Research facilities do, but the everyman trying to watch YouTube videos does not. SLMs, they contain millions to billions of parameters. It stands for smaller language models. I have a friend who's like, they're not small, they're like medium-sized. You can't call mine a small language. Smaller, dude, smaller. Smaller language models contain millions of billions of parameters. You can compare that to frontier models that they contain billions or even a trillion parameters. And they use less energy than large language models, and they can still produce correct responses. And they are so light that they can be put on devices. My phone, which I left in my chair, but I usually like to bring out at this moment, Pixel Pro, it ships with Gemma Flash on device. And this is a comparison chart here. You can think of, for every 1 billion parameters you get, it costs about 2 gigabytes in FP16. Most smaller language models for mobile and web, they're deployed with quantization, which can have recorded the disk and memory requirements. This is a grid giving you an example, which I'm standing in front of, very conveniently. Now, let's compare the power usage of these different models. So if we're going to use LLMs energy consumed for inference, this is the gold metric here. SLMs, smaller language models, can use up to about a quarter of that energy to produce the same result. Of course, this is with appropriate prompting, blah, blah, blah. Task-specific models will use less than half of that, so we're talking maybe an eighth of the same cost. That's in terms of energy consumption. We're not including water, we're not including the cost of actually paying for calling the API, which would be zero if you're hosting some of these models yourself. So the benefits of small local AI are many. They're more secure, work offline, no fees, especially if you're using an open source model, more efficient, and lower latency, because you're not round tripping to a server in God knows where, exposing your data. So how do you pick the best model for the job? I have a framework for this. Here's how you do it in 4 steps. First, you want to prove that what you're trying to accomplish is possible. This is where foundation models are super useful. Just prove that you can get it to execute a complex task with the right prompting and access to the right resources. You want to set your success criteria. What does good look like? Foundation models are actually really helpful for generating your success criteria. And then you want to test. You start with the smallest models possible, the tiniest ones, and you run them against your success criteria until you get to a size that's maintainable. And then, of course, you select the smallest one that gives you the right feedback. All right, I really tried to come up with a cool acronym for this, but the best I got was pss, pss. I really tried. I'm working on it. If you have an idea for an acronym for this, let me know. I want it to be stickier than pss, pss, pss. You're right, it probably does mean something really cool in cat. Now, an easy way to summarize this is prototype big, deploy small. You can use a foundation model for prototyping. It does everything. You don't have to worry about, which visual model do I want to use? No, use multimodal. Go for it. Those inference costs, those are a research budget. But then you convert parts of it to smaller language models and specialized models for production as you can get them to meet your success criteria. Ba-boom. All right. deployment. This is actually the part I find super fun, because obviously I want the future in my pocket and take it with me everywhere and available offline. The biggest thing to remember about deployment is to keep the model near your data. The less you're shipping data around, the better. The less you're exposing it, the less the latency costs. So basically, sometimes this means you want to keep everything remote. You don't want it on the user's device. Like, connectivity is a constant. You know, if they're in an office environment and they are wired in, you have 100% uptime with that connection, of course you can use a remotely hosted model. And data, if it's on the remote server, you want to keep it near that data. For instance, say you have a securely locked down database of personally identifiable information. Yeah, you're probably going to want to put your model next to that and not on the terminal. And of course, if the usage involves complex tasks, or bandwidth is high, or the responses are small, remote is wonderful for that. And if you have security processes and procedures in place, perfect. And of course, if you have a limited electrical supply, a remote inference can cost the user less. This is actually really important for mobile devices. When I'm using the AI features on my Pixel, it does like to eat the battery. And yes, the chips will get better. The chips will get better, and the batteries will last long. Yeah, we know. But if you're in a situation like if the phone has less than 10% battery, you might just want to use an API call at that time to a small language model on a remote server, just so that your user doesn't have a brick on their hand. No bricks, no bricks. So, deploying locally, when offline mode is required. Your user's got a spotty network, they're in the field, or maybe they're in a mine or secure facility that doesn't have connectivity to the outside world. Data is on the device. We're talking user photos, text input, recordings. If the data's on the device, why are you sending it somewhere else to be processed? That's ridiculous. And the usage is high frequency. Chat, translation, real-time analysis, doing it there on the device will definitely help with those compounding latency costs. And bandwidth is low or the outputs are large. Yeah, you don't want to have to wait for a generated video for a TikTok feed that you're creating. Now, if the data needs compliance or extra security, for instance, health or finance, it's often just easier from a compliance standpoint to leave it on the device and process it there. And of course, if the electricity is reliable, such as a plugged-in desktop, or other power-tolerant use cases, which I struggle to identify right now. Maybe you know that they're plugged into a battery somewhere. And choosing the right location. Foundation models, well, they'll never be on device. You can't deliver them to the device, and they are 100% remotely. But with smaller language models, you can choose between whether you want to deliver it, use the one locally, or host it remotely. With task-specific ones, they're never going to be preloaded onto the device, at least today. So you might have to deliver them. So in short, deploy local first if the app has offline requirements or high-frequency use, sensitive data access. Choose remote first if we need a lot of complex reasoning, have large models, or infrequent use. And choose a hybrid approach, where you download small models while using APIs and switch over to the local models when ready. We already are seeing this out in the field on the web. I'll show you an example shortly. So, we know deployment, and we only have 7 minutes left. So let's focus on the 3 local strategies. You can host the model, you can use the device's model, or you can deliver the model to the device. So I'm curious, before we get too far gone, how many of you use a personal agent like Claude, ChatGPT, or Gemini? I'm not talking about, oh yeah, wow. And those of you who aren't, is it because of the money? Is it because it's too expensive? Okay, I see money is no object with this crowd. I'll assume it's something else. Well, for the rest of you, you can save some money. I'm about to show you that for most of the stuff I personally use Claude for, I can be using a local model. I don't actually have to use Claude. I do, but I don't have to. I love ichthyosaurs. This is what I go on Wikipedia and read about on a regular basis. Ichthyosaurs are ancient reptiles, not dinosaurs, marine reptiles, not related to dinosaurs, that look, for all intents and purposes, just like dolphins. And they've been dead for years. And one day I looked at them and I said, my gosh, could they have echolocation? So, here's an example of, I asked Claude to tackle the question, and I asked the agent I put together with an SLM to answer the same question. And you can see them running side by side. I'll show you how to set the agent up in a minute. But essentially, Claude, I ran this many times, and out of 10 times, Claude answered incorrectly twice. And this is the second one. Claude says, oh, yeah, ichthyosaurs might have had echolocation. That is incorrect. As you can see over here, Qwen comes up with a lot more evidence. This is just the body of knowledge available to them. They're not searching the internet. They're merely working from what they've been trained on. And Qwen actually comes up with the better answer more often, which is not likely. They all have huge-ass eyes. They were designed for hunting by sight. There is no evidence of any audio equipment on this animal, and you could tell from the bones. So I was actually surprised. They're supposed to get it both kind of accurate, but Claude answered incorrectly. The important thing is that the smaller LLM here used 73% less energy to answer the same question with the same arguments. Of course, it was a bit slower to do it, but I'm also using it in an unoptimized system, whereas Claude has been optimized. So it was able to do this with no internet access, only 8 gigabytes of RAM, and running on my laptop. You can build your own in 3 easy steps. You go to ollama.com, you download it. It lets you run and build models locally on your device. Then you get yourself Qwen 3 with 4B. And then you go install Goose. Goose is, I don't know how to describe it. I'm going to call it a personal agent harness. All you do is you plug in the model that you want. You can use API calls to a foundation model, or you can use a local model running with Ollama. It uses MCP tools, it supports MCP UI, all the stuff that you would expect from ChatGPT or Claude, but you BYOLLM, or SLM in this regard. If you're curious and you want to set one up yourself and see what it's like to use it, perhaps even customize it to do what you want it to do a little bit better than the other guy, I have a video walkthrough. It's a lot of me talking, but it'll tell you what to do. All right. Option number 2. What about models that are on the device already? I mentioned that my phone, for instance, has a Gemini model on it. Well, Chrome these days, ever since I think it's 128, ships with Gemma Flash built into the app. One day we're going to have a lot of little SLMs in all these different apps. I'm not excited about that day. But let me show you a little bit about what that could look like. Here we've got Prompt API. This is the API that the Chrome team has proposed that uses the browser's local LLM to perform inference. I was told that there would be only demos and no slides, so I'm going to show you this. Let's do it. So, the idea was, don't you hate it when you're a 2011 Tumblr girly and you're posting pictures and you got the haters coming in and saying like, you suck, definitely a 2, and you're like, God, man. And then you get into Twitter fights. This is my history. So I thought, wouldn't it be great if we had a way to make people pause in their client and say, yo, what you said wasn't very nice. Maybe you could phrase it differently. So let me blow that up a bit. If I submit this comment, device is not eligible. Oh, that's because we're in Comet. This only works in Chrome. All right, there we go. Okay, so it's available. Model may download on first use. I thank you. You suck. And submit the comment. Analyzing, as you can see, it's not the most fast experience ever, but it is local, and it does work when I'm not connected to the internet. And it says, oh, maybe you should reconsider. The comment, you suck, is a direct personal attack and constitutes hostile and aggressive tone. I definitely need to work on the prompt. This could be a lot shorter. Anyway, try this instead. It's like, I don't quite agree with that perspective. I see it differently. Okay, definitely need to work on the prompt, but check it out. Okay. No, this is all live. I put this together. Okay, and I was like, it's flirtatious comments are okay. I want to be able to say someone's cute. Let's see. See, if comment's problematic, provide constructive alternative, maintains core message, but presents it objectively and responsively. keep in mind these are comments about appearances on photos, not about philosophical disagreements. There you go. All right, let's see if that fixes it. We'll find out. Remember, like, the prompt, it's all in the prompting. All right. You look terrible. All right. This is a lot of fun. I've had so much fun saying different things to it. Direct personal attack. Instead of focusing on appearance, consider the lighting in this photo isn't very flattering. Or this photo isn't quite capturing your best side. Okay, let's find out. There you go. Yay! It allowed me. All right, so this is just one of the fun new features that you can add on the client side. Brilliant. Okay, back into it. It works, but it's also mirroring, and that's not what I wanted. Hang on, change, extend. We can do this. Extend to display. Okay, moving on. Anyway, if this excites you, you can get your early access to this API at this handy-dandy URL, which I'm totally blocking, but I'll put a link. Just go to my socials, there'll be links. All right, so the future, what can we expect? As specialized chips are becoming more commonplace on devices, onboard AI models are pretty much standard in flagship smartphones from Samsung, Apple, and Google. And they're becoming more common in operating systems like the more recent Windows machines and, of course, in Macs. You can access Gemma from within Chrome, and you can use Apple Intelligence in Apple-type projects. They have their own prompt API that you can go read about, and their dev tools, etc. NVIDIA called SLMs, or smaller language models, the future of agentic AI. Because they're on device, they're small, they're pretty good at making knee-jerk decisions, as you saw when Gemma was telling Qwen what to do earlier. I've worked with both of them, and I totally expect Gemma to be kind of like that with Qwen. I totally see it. They have that dynamic. So, increasingly, AI tasks, they can be completed at the edge. We do not need to keep round tripping with foundation models. We have all the things that we need. So get moving. Choose local, small AI when you're working on projects. Take a look at smaller language models and specialized models. They're more efficient, and they can meet their users where they are. Remember to prototype big and deploy small. Using foundation models, think prove it, define it, test it, and select the smallest. And generally, keep your data where your model is, or vice versa. In this way, we don't have to set the world on fire to use AI. We just have to think a little smaller. All right, you can find my socials, and I'll post those links to all these fun resources. If you want to talk about how the web and AI interface together, or small language models in general, hit me up. I'm around the rest of the day.